Electricity is everywhere. Our phones, refrigerators, air conditioners, and a whole lot more. But electricity is not limited to just those things. It's also in lightning and the friction produced when rubbing two objects. Electricity cannot be created or destroyed. So, when did we actually first learn about electricity? And when did we learn to control it? We will now discuss about the history of electricity and how it went from amber and wool to these modern-day appliances.
Amber is a good conductor, meaning that it easily lets electrons and protons pass through. When rubbed, it acquires a positive charge and therefore causes object to be charged by induction, since the positive charge attracts negative charge of the opposite.
In the year 1600, in London, England, roughly 2 centuries after Theos of Miletus first had his brush at electricity, William Gilbert, the physician to Queen Elizabeth I, discovered that other things besides amber can also attract things, and he called these things electric, from the Greek word electron, which means amber, and this became the basis for our modern word electricity. He also invented a machine called the versorium, and it looks a lot like this. It's basically just a piece of light wood over an upright rod. And then, when an object, such as paper, is rubbed and put near the versorium, the pointer turns to it, making the thing electric. Well, things that he rubbed but did not make the versorium pointer turn is called non-electric. Although unknown to him, William Gilbert really first discovered and used the term electric and non-electric. He made electricity what it is today, and what we know about it is thanks largely to him.
Charles Leclerc, a French chemist, continued the work of Gilbert, but this time discovered the two charges of electricity receivers, the negative charge and vitreous, the positive charge. He also noted the difference between conductors and insulators, calling them electric and non-electric, and discovered that like charges repel while opposite charges attract, contradicting the theories of early scientists who believed the electric properties depended on the color of the
A German physicist invented the Leyden jar, which was the world's first electrical capacitator. With this, he discovered that electricity was controllable. The Leyden jar consists of a nail stuck to a cork and a medicine bottle. He knew that both the nail and the jar was capable of temporarily storing electrons.
The Leyden jar is a cylindrical container made of electric and insulator like plastic or glass, with a layer of metal foil in the inside and outside, which the surface is grounded, then a charge is given to the inside surface. This gives the outside an equal but opposite charge.
Benjamin Franklin was one of the founding fathers of the United States and in many ways was the first American. Franklin was a leading author, politician, scientist, inventor, and diplomat. As a scientist, he was a major figure in the history of physics for his discoveries and theories regarding electricity.
Let the experiment be made.
Benjamin Franklin proposes his most famous experiment, flying a kite through a storm with a key attached to it. He wanted to prove that lightning was electricity and that resonance charges and vitreous charges were the exact same thing but in different pressures. He He was the first to label the charges as negative and positive, and the first to discover the principle of conservation of charge, which is defined as the principle that electric charge can neither be created nor destroyed. The net quantity of electric charge, the amount of positive charge minus the amount of negative charge in the universe, is always conserved.
In his writings, Franklin indicates that he was aware of the dangers and offered alternative ways to demonstrate that lightning was electrical, as shown by his use of the concept of electrical ground. If Franklin did perform this experiment, he may not have done it in the way that is often described. Flying the kite and waiting to be struck by lightning, no, that is not it, as it would have been extremely dangerous. Instead, he used the kite to collect some electric charge from a storm cloud, which implied that lightning was electrical. Charge conservation is a physical law that states that the change in the amount of electrical charge in any volume of space is exactly equal to the amount of charge flowing into the volume minus the amount of charge flowing out of the volume. In essence, charge conservation is an accounting relationship between the amount of charge in a region and the flow of charge into and out of that region.
In recognition of his work with electricity, Franklin received the Royal Society's Copley Medal in 1753, and in 1756 he became one of the few 18th century Americans elected as a Fellow of Society.
In Philadelphia, Franklin conducted his experiment and successfully extracted sparks from cloud, proving that lightning was electricity. Later on, he invented the lightning rod, which was invented the electric light bulb, which proved to be the most life-changing invention of the 21st century. A year later, he patented an electric distribution, which will benefit the light bulb electricity, became available worldwide and began Edison Electric, an electric company that provided people with energy. Before this, however, Edison had failed numerous times in inventing the light bulb. Finally, he was able to succeed the light bulb.
A long way from what Tales of Malthus first discovered about electricity. But perhaps we have gone too far that we depend on it too much, to the point that we only need electricity in our lives. I speak behalf of the group to say that electricity is useful for letting us do our assignments and connecting with people in other places. But it is cutting us from our relationships to the real people, making us somewhat antisocial, and giving us access to information that are inappropriate. In short, electricity is beneficial, but we should not depend on it too much. Thank you.